Welcome to the deep dive. Today we're tackling something, well, pretty fundamental in Java, how we control inheritance.
Yeah, it's evolved quite a bit.
For years, final was kind of our go-to tool, right? But it doesn't always cut it in every situation.
Exactly. It has its place, but limitations too.
So we're going to explore sealed classes. They landed in Java 17 and offer a much more precise way to handle class hierarchies.
Especially when you know up front exactly what the valid subclasses should be.
Right. And our focus for this deep dive is really getting to grips with sealed classes, particularly if you're prepping for senior Java interviews.
It's a good point. Explaining these concepts clearly is crucial.
And given we're audio only here, we're going to be super careful about how we verbalize the code. Precision matters.
Definitely. Okay, let's get into it.
So maybe start with the problem final didn't quite solve.
Sure. So final is great for stopping further subclassing of one specific class. You make my final class final, and nobody can extend it.
Okay, simple enough.
But it doesn't prevent someone from going back to the parent class, the superclass, and extending that directly. You think about like a JSON library example. You might have an abstract JSON value base class.
Makes sense.
And then you create concrete subclasses like JSON array and JSON number, and maybe you make those final.
Right, so no one subclass is JSON array.
Correct. But someone could still write public class JSON comment extends JSON value.
Yeah.
And suddenly you have a subtype that maybe breaks assumptions in your library because, well, comments aren't really standard JSON values.
Yeah, that could lead to unexpected bugs.
Totally. Bugs often pop up from these unexpected subtypes, messing with your code's logic. Sealed classes, they give you a language-level way to prevent that. Makes the code more reliable, easier to reason about, especially in bigger systems.
Okay, so final on the kids doesn't lock the door on the parent's house, basically.
That's a good way to put it, yeah.
So how do sealed classes give us that tighter grip?
Well, a sealed class lets you explicitly list exactly which other classes are allowed or permitted to extend it. And it works for interfaces, too. A sealed interface restricts who can implement it. The magic happens with the permits clause.
The permit clause, right.
So for that JSON value example, you could declare it like this. Let me verbalize carefully. Public abstract sealed class JSON value permits JSON array, comma, JSON number, comma, JSON string, comma, JSON boolean, comma, JSON object, comma, JSON all, then open curly brace, ellipsis, close curly brace.
Okay, hold on. Let me try that back. Public abstract sealed class JSON value permits JSON array, comma, JSON number, comma, JSON string, comma, JSON boolean, comma, JSON object, comma, JSON all, open curly brace, ellipsis, close curly brace.
Nailed it.
So it's like you're defining a closed club. Only these members are allowed in.
Exactly. From an API design view, it makes your intended extension points crystal clear. It's a stronger contract for users, and it makes evolving the library safer later on because you know all the legitimate subtypes.
And what happens if someone tries to sneak in? Like with that JSON comment example.
Compiler error, straight up.
Yeah.
If you write, say, public class JSON comment extends JSON value, open curly brace, ellipsis, close curly brace. The compiler sees JSON comment isn't in the permits list for JSON value and says, nope, not allowed, error.
Wow. Okay, so the compiler enforces it right then and there.
Yep, which is huge for maintaining the hierarchy's integrity and, making sure it actually models your domain correctly. Like you said, comments aren't standard JSON values, so preventing that extension is exactly what you want.
That feels much more solid than just relying on final scattered around.
It really is.
So what are the big wins? What advantages does this give us in practice? That compiler enforcement part really makes sense now. It's interesting how a seemingly small feature impacts design.
Yeah, a huge one is how it enables exhaustive switch expressions, especially with pattern matching, which came along around the same time, Java 17 onward.
Okay, pattern matching in switch. How does that work here?
Let's take that type method in our JSON value class. You could write it like this. Public string type, open parenthesis, close parenthesis, open curly brace, and return switch, open parenthesis, this, close parenthesis, open curly brace.
Okay.
Then your cases, case JSON array J, hyphen greater than, string literal, open double quote, array, close double quote, semicolon, then case JSON number J, hyphen greater than, string literal, open double quote, number, close double quote, semicolon, case JSON string J, hyphen greater than, string literal, open double quote, string, close double quote, semicolon, and so on for Boolean, object, and null.
Right, let me try verbalizing the whole structure. Switch, open parenthesis, this, close parenthesis, open curly brace. Then the case is like case JSON array J, hyphen greater than, string literal, open double quote, array, close double quote, semicolon. And the next one, case JSON number J hyphen greater than, string literal, open double quote number, close double quote semicolon, and the others a string boolean, object null, and finally close curly brace.
Perfect. And here's the key part with sealed classes. Because JSON value is sealed, and we listed all its permitted direct subclasses in that permits clause, the compiler knows that list is complete. It knows those are the only possible direct types this could be. So you don't need a default clause in the switch.
No default needed. Because the compiler can prove you've covered every single possibility listed in permit.
Exactly. It verifies exhaustiveness.
Yeah.
This adds a huge layer of safety. You won't suddenly hit a runtime error because some unexpected subclass popped up that your switch didn't handle. It makes the code way more robust and maintainable.
That is a fantastic benefit. Really reduces potential runtime surprises.
Yeah.
What else? Any other advantages?
Well, related to what we said earlier, it allows for much more accurate domain modeling.
How so?
If you have a concept in your domain that naturally has a fixed, known set of variations, sealed classes let you model that directly in the code. You prevent weird, unintended extensions that don't fit the model.
Like our JSON comment example.
Precisely. The JSON standard defines specific value types. Sealed classes let us enforce that boundary right in the type system.
Okay. And you mentioned something about where these subclasses have to live.
Ah, yes. Location rules. All the direct subtypes listed in the permits clause must be in the same package as the sealed class.
Same package. Got it.
And if you're using Java modules, they have to be in the same module as well.
Makes sense. Keeps things close.
There's also a neat variation. You can actually declare a sealed type without a permits clause.
Oh, what happens then?
In that specific case, all its direct subtypes must be declared in the very same source file.
Wow. Okay. So even tighter control if you need it, like for inner classes or very closely related types.
Exactly. More options for library designers.
So it's about keeping things tidy and explicit. Now, what about the subclasses themselves? If JSON value is sealed, are JSON array and JSON number automatically sealed too?
Ah, good question. No, not automatically. The subclasses of a sealed class have to explicitly state their own intentions regarding further inheritance.
Okay, so they have choices.
Yep, 3 choices. First, they can be declared final.
Meaning no more subclassing. Done.
Correct. Second, they can be declared sealed themselves.
Ah, so they continue the pattern with their own permits clause.
Exactly. They define their own restricted set of permitted children.
Okay. And the third option?
They can be declared non-sealed.
Non-sealed.
What does that do? That basically breaks the chain of sealedness. A non-sealed subclass becomes open for extension again, just like a regular class before Java 17. Anyone can subclass it.
Interesting. So you can choose to open up specific branches of the hierarchy.
Precisely. The syntax, by the way, is public non-sealed class. Some class extends sealed parent, open curly brace, ellipsis, close curly brace. Note the hyphen in non-sealed.
Got it. Non-sealed. This is actually quite important for architects, right? Deciding where to enforce constraints and where to allow flexibility.
Absolutely. It helps enforce the intended design model across a team, preventing accidental subtypes that don't fit. Leads to more cohesive code.
Could you show how this might look if we reorganized our JSON example a bit? Maybe introduce an intermediate level.
Sure. We could do something like this. Public abstract sealed class JSON value permits JSON object, comma, JSON array, comma, JSON primitive, open curly brace, ellipsis, close curly brace.
Okay, so JSON value now permits JSON object, JSON array, and a new one, JSON primitive.
Right. And then JSON primitive could itself be sealed. Public abstract sealed class, JSON primitive extends JSON value permits JSON string, comma, JSON number, comma, JSON boolean, comma, JSON null, open curly brace, ellipsis, close curly brace.
Ah, I see. So JSON value controls the top level, and JSON primitive controls the grouping of the simple types like string, number, boolean, and null.
Exactly. You get these nested layers of control over the hierarchy.
That makes a lot of sense. And you mentioned non-sealed. Where might that be useful? Can you give an example?
Yeah, think about maybe modeling an XML document object model, a DOM. You might have a top-level abstract sealed class node.
Okay, like node.
And it might permit direct subclasses like, say, element, text, comment. Maybe those are final or sealed. But for element, you might want people to be able to create specific types of elements, like HTML elements.
Like div or img.
Exactly. So you could declare element as non-sealed. Public non-sealed class element extends node, etc.
Okay.
And then other people, or maybe you in another part of the code, could write Public class HTML div element extends element, open curly brace, ellipsis, close curly brace, or public class HTML element extends element, open curly brace, ellipsis, close curly brace.
I get it. So node is sealed, controlling the main types, but the element branch is explicitly opened up for further, maybe domain-specific extensions.
Precisely. It gives you that flexibility where needed within an overall controlled structure.
Very clear. Now, earlier you touched on sealed being a contextual keyword. What exactly does that mean for us developers?
It basically means the word sealed only acts like a keyword in the specific context where it modifies a class or interface declaration.
So unlike class or public, which are only keywords.
Right, you can actually use sealed as a variable name.
Really?
Yep. Writing int sealed equals 1 semicolon is perfectly valid Java code. The compiler understands that sealed here is just an identifier, a variable name, because it's not in the context of modifying a type.
Huh. Okay, that's good to know.
If you tried int class equals 5 semicolon, that would be an error because class is always a keyword.
Got it. What about non-sealed? Can I use that as a variable name?
No, not directly like that because of the hyphen.
Oh, right, the hyphen.
If you wrote something like int non equals 0,
What?
semicolon, followed by non equals non-sealed, semicolon.
Yeah.
The compiler would interpret non-sealed as subtracting a variable named sealed from the variable non-sealed. It sees the hyphen as the subtraction operator.
Okay. So sealed is non-sealed is treated like an operation if used incorrectly as an identifier. Little nuances.
Exactly. Things to be aware of.
Definitely. And for those listening who are prepping for interviews, especially senior ones, getting the terminology and the verbalization right is super important, particularly if you're describing code over a phone screen or just talking through a design.
Absolutely critical.
So let's try a couple of quick interview-style questions focused on that precise verbalization. First one. Describe the syntax for declaring a sealed class named shape that permits two subclasses, circle and rectangle.
Okay. The precise answer should be public abstract sealed class shape permits circle, comma, rectangle, open curly brace, ellipsis, close curly brace. You'd want to clearly state each part. Keywords, names, the comma separator, and the braces.
Excellent. Okay, next question. Explain the different ways a subclass of a sealed class can be declared regarding further inheritance, and provide the keywords for each.
Right. So the answer should cover the three possibilities. A subclass can be 1. Final stopping further inheritance, 2. Sealed continuing the sealed hierarchy with its own permits list, or 3. Non-sealed opening it up for any arbitrary subclassing. And the keywords are final, sealed, and non-sealed.
Perfect. And one more. Walk me through a scenario where using a sealed class is clearly better than just making all its direct subclasses final.
Okay, for this one, you'd really want to highlight two main things. First, the benefit for exhaustive switch statements. Explain that because the sealed class declares all permitted direct subtypes, the compiler can verify switch completeness without needing a default clause. This makes the code safer.
Right, the compiler guarantee.
Exactly. And second, emphasize the clearer domain modeling. Sealed classes let you express the entire set of allowed direct children right there at the parent level. It's a more explicit and robust way to define the intended hierarchy compared to just putting final on the children, which, as we discussed, doesn't stop other direct children from being added later.
Great points. Really focuses on the compiler benefits and the explicit design intent. Now, we've mostly talked classes. You mentioned interfaces, records, and enums briefly. Can we elaborate just a bit? We've seen how sealed classes are a game changer for inheritance, but does this idea apply elsewhere in Java?
It does. Interfaces can also be sealed. So public sealed interface, my sealed interface, permits implementing class A, comma, implementing class B, etc. It works very similarly, controlling which classes or even other interfaces can implement or extend the sealed interface.
Okay, so sealed interfaces too. What about records and enums?
Well, records and enums are implicitly final by their nature. You can't extend a record or an enum.
Right.
So because they can't be extended, it doesn't make sense to declare them as sealed themselves. There's nothing to permit or restrict.
But can they implement a sealed interface?
Oh, absolutely. A record or an enum can implement a sealed interface, provided they are listed in that interface's permits clause, of course.
Okay, that makes sense. And just to round out our discussion on inheritance control nuances, can you give us a quick reminder about default methods? Specifically, the rule when a class extends another class and implements an interface, and both have a method with the same name.
Sure. That's the class's win rule. If a class C extends class S and implements interface I, And both S and I provide an implementation for the same method, say void do something. The implementation from the superclass S is the one that gets inherited by C.
So the class implementation takes priority over the interface's default implementation.
Exactly. It's different from when a class implements two interfaces with the same default method. In that case, the class must provide its own implementation to resolve the ambiguity. But when it's class versus interface, the class implementation wins automatically. It's a related piece of the inheritance puzzle, though distinct from sealed types.
Got it. Good distinction. Okay, so wrapping this up, we've really dug into sealed classes in Java 17.
We have.
We've seen they offer this powerful, precise control over inheritance, really going beyond what final alone could do.
Definitely helps create more robust code, especially with those exhaustive switch checks.
Yeah, and enabling that more accurate, explicit domain modeling seems like a huge win, too, representing those fixed sets of subtypes right in the type system.
Absolutely.
And as we hammered home, being able to talk about this clearly, the syntax, the why is so important, especially if you're aiming for or are in those senior technical roles.
Precisely. Knowing when and why to use sealed classes really shows a solid grasp of OVRO design and modern Java features.
So now that we've explored sealed classes, we're really curious to hear from you, the listeners. Where do you see sealed classes being particularly useful in your own projects? What kind of scenarios come to mind?
Yeah, we'd love to hear your thoughts.
Drop your ideas and examples in the comments wherever you found this deep dive. Let's keep the conversation going.